Today's lesson is on dimensional analysis. Dimensional analysis is one of the most useful skills you will learn in chemistry this year. We use dimensional analysis in chemistry to convert one unit to another. Now, converting one unit to another is not new to you. For example, we do this simple activity in class where I ask my students to write down how tall they are. You might answer something like 5 feet 7. If I ask you how tall you are in inches, you could easily make the conversion and answer 67 inches. If then I ask you, well, how tall is this in centimeters? Again, with a simple calculation, you would tell me 170 centimeters. So converting from one unit to another is neither new nor difficult, but the process of using the steps that I'm going to lay out for you in dimensional analysis sets the foundation for probably the most important skill you will learn in chemistry this year. That skill is called stoichiometry, or dimensional analysis on steroids. Now, in asking you to convert the measurement of your height from inches to centimeters, the first thing that you did was you came up with an equality between the two units. You maybe recognized that 1 inch equals 2.54 centimeters. In this process of dimensional analysis, we utilize these equalities as conversion factors to change one unit to another. A conversion factor turns an equality into a ratio, with one value on top and one on the bottom. Because these two values are equal to each other, the ratio then is equal to 1. The conversion factor can be set up in either way, with 1 inch as a numerator or as 1 inch as the denominator. Each ratio is equal to 1, so if we multiply any number by this conversion factor, we're going to actually be multiplying that number by 1. The value of the number does not change, only the unit. That's the whole point of dimensional analysis, is we're trying to convert one unit to another without changing the value. So let's look at how we use these conversion factors in dimensional analysis. These are the steps used in solving a problem using dimensional analysis. It might be helpful to write them down and keep them next to you as you practice the process. Number 1, write down what is given. Number 2, use an equality to set up a conversion factor. This is the process we just practiced with the equality between inches and centimeters. Number 3, do the math. Multiply the numerators and divide the denominators. So let's see how we use these steps in solving dimensional analysis problems. So if you are following along with my worksheet, this is problem number 1 on the worksheet. All right. Convert 17.5 quarts to liters. Number 1, write down what is given. 17.5 quarts. Number 2, use an equality to set up a conversion factor. So what we want to know is, how does the quart relate to a liter? Now, you might have a conversion sheet that your teacher gave you. You might just automatically know this, and if you don't have either, look it up on Google. So when we type in quarts to liters on Google, we get 0.946 liters equals 1 quart. Now, this is the equality that we're going to use in our conversion factor. And remember, because these values are equal to each other, making a ratio out of them creates a conversion factor that's equal to 1. So now we need to decide between these two options for our conversion factors, which one we're going to use in the dimensional analysis problem. We've been given quarts, 17.5 quarts, so we need our quarts to cancel. So we will end up using the conversion factor that puts quarts on the bottom so that we can cancel out our quarts. We're going to use this one. We'll set up the problem using the conversion factor like this. And because this sets up to cancel out quarts, we are left with liters, exactly what we are asked for. Step number 3, do the math. Multiply the numerators and divide by the denominators. You might want to follow along with your calculator to make sure that you're plugging this in correctly and coming up with the same answer. 17.5 times 0.946 equals 16.6. Liters is the unit. The quarts cancel out, and liters is our final unit. All right, let's try another one. Again, if you're following along on my worksheet, this is example number 2. Convert 38.75 square feet to square miles. Number 1, write down what's given. 38.75 square feet. Number 2, use an equality to set up a conversion factor. Again, you can Google this to find out the equality. 1 mile equals 5,280 feet. Well, you know, we don't need this straight relationship. What we need is a squared relationship. So all we're going to do is square the entire equality. And in doing so, we get 1 squared equals 1 miles squared. 5,280 squared equals 27878400, and then feet squared, of course, is feet squared. So these are our two options. We can have the 1 mile squared on the numerator, or we can have the 1 mile squared on the denominator. Well, look at what's been given. We know that we need the feet squared to cancel out right here. So we need to use a conversion factor that puts the feet squared in the denominator. We're going to use this one. Setting up the conversion factor like this to cancel out the feet squared. And miles squared remains, exactly what the question asked for. Step number 3, do the math. Multiply the numerators and divide the denominators. 38.75 times 1 divided by 27878400 equals 1.39 times 10 to the minus 6 miles squared. All right, let's try one more. But this time, let's look at using a 2-step process rather than the just 1 step. So even though you can easily Google the relationship between grams to pounds to make this a 1-step problem, we are going to purposefully make this a 2-step problem for the practice. Once we advance to stoichiometry, you'll need to be well versed in multi-step dimensional analysis problems. If you're following with my worksheet, you'll recognize that this is problem number 3. So let's get started. 3598 grams into pounds. Write down what is given. 3598 grams. Number 2, use an equality to set up a conversion factor. So as stated, we will approach this problem in 2 steps. We will convert our grams to ounces and then our ounces to pounds. The equalities listed show that 1 ounce equals 28.35 grams and 1 pound equals 16 ounces. Conversion factors for each equality would look like this. We know that we need grams to cancel out. Right here, what's given. So we're going to choose the conversion factor that puts grams in the denominator. This will place ounces in the numerator. So for the next conversion factor, we're going to need to choose the conversion factor that cancels these ounces out. So we're going to use this equality because it's going to have ounces on the bottom. Setting these up in the equation looks like this. My grams cancel. My ounces cancel. Step number 3, do the math. Multiply the numerators and divide the denominators. Again, follow along with your calculators to make sure that you are plugging this in correctly and able to get the right answers. 3598 divided by 28.35 divided by 16 equals 7.932 pounds. All right, so this wraps up the lesson on dimensional analysis.